Hello, my name is Walter Unglaub, and this is 3 ways an unbalanced force can affect an object's motion. So, if we have a point mass, and it represented by this dot, and there is some net resultant force that is not equal to 0, meaning it's represented by an arrow indicating direction, and it has some size, some magnitude. This implies that the total forces on this object is not balanced. So a force is defined as the time derivative of the momentum. But because we're assuming that the mass is constant, when we calculate this out, we have the time derivative of the mass times the velocity, and this is equal to the mass times the change in velocity over time plus the velocity times the change in mass over time. And since this mass is not changing, we recover our F equals ma formula because the change in velocity over time is acceleration. So if we have a non-zero or unbalanced force in our physical system, and this is constant, that implies that the acceleration will be non-zero. So that is the first of 3 ways in which the motion will be changed. The acceleration is not equal to 0, so the object will accelerate. A second way in which it changes its motion is the fact that because the acceleration is not equal to 0, the final velocity will not only depend on the initial velocity, but also on the acceleration over time. So this is the initial velocity, this is the final velocity, this is the acceleration that's non-zero, and time, of course, will increase. So the final velocity will increase linearly with acceleration. So this is a second way in which the motion of the object is changed. Its velocity will change over time. Finally, if we examine the kinematic equation for position, which can be derived by integrating the velocity equation with respect to time, we have the final position is equal to the initial position plus the initial velocity times time plus 1/2 the acceleration times time squared. So we see that not only will the position change linearly with respect to time for the with a given initial velocity, but it'll change quadratically with respect to time in the event that the acceleration is non-zero. And indeed, that is the case here. So obviously, the position of the object will change. Its position will change, its velocity will change, and the acceleration will remain constant, but it will be non-zero. So this is 3 ways in which the motion of the object will change due to an unbalanced force. My name is Walter Unglaub, and this is 3 ways an unbalanced force can affect an object's motion.